Alright, second devlog. It is December 8th, 2024. A lot has changed. So, um... sorry, I'm still kind of tired, still waking up. I got... My dad gave me a few books. One of them being... Algorithms in C, 3rd edition. Fucking amazing book. I am currently in chapter 2, and it's really fucking good. So, object-oriented programming is the least efficient way to program technically. But it has benefits, specifically in human design. And, you know, there could actually be benefits to object-oriented programming that are genuine performance benefits and efficiency benefits. But so far, what I've seen is that object-oriented programming is inefficient if you're only going by pure computational efficiency. If you have a big project with a lot of people, object-oriented programming can help organize things for humans. But in my opinion right now, so far that I've experienced, which is not a humongous amount, so far, still looking like it's technically less efficient. That being said though, I have grown to like my autistic brain wants so badly to be the guy that, you know, makes the most efficient program, you know? And goes against the grain. And to a degree, I want to do that. But I think past that degree, you just become, you know, unworkable with other people. Like nobody wants to work with somebody who is that perfect and efficient, if you can even attain that, right? That's assuming I could even attain that, which is, you know, practically impossible. But even if you could, you know, that's getting into the level of, like, you know, great entrepreneurs who were, you know, really good thinkers, but not very good people, you know what I mean? People, not very good talking to people. Effectively speaking, like, you know, you have to weave that balance of human and machine when programming, even if you're programming by yourself. Although you can stretch that a little bit more when you're programming by yourself, you know, you can try and be more efficient and less humane with your programming. I also have come to terms with the fact that I know a lot less about OpenGL and rendering than I thought I did. Now, obviously, I did learn OpenGL and I went through the first few modules. Like, it's not like I fucking know everything there is to know. But, like, specifically, rendering more than one thing to screen, as in something with its own unique mesh in a different position, requires techniques that I did not even know existed, because I didn't even know that you had to do that because I didn't think about it. But yeah, you send all the vertex data and offsets and shit to the shader. You have to do that for every single object, every single instance of a mesh that is going to be in a different place. Because, you know, it's like, the way that I've written it, at least, or the way that the tutorial has written it, is that it has a model offset. The shader, the output, has the perspective transformation matrix, the perspective matrix, transformation matrix, which I believe is the camera, but it might be separate, because I think there is, like, whatever. But the point being, it has its own model offset for the vertex positions, which is for the model. And since there's only one object being drawn to screen, it works. But as soon as you put another object on the screen, everything gets offset by that. So it's like that model offset is like the global coordinates or global position. But you have to set that for every single object, not just once. because if you set just once, every object uses that. It's a terrible way of describing it because it's no such thing as objects, it's all just pixels and vertex data, but roughly speaking, that's kind of how it is. So when I have a rendering command and it works. I have a rendering function, not a class, rendering function, and it works. Now, granted, it is not very, it's very, very like almost hard-coded, pretty close to that, but it does take in an arbitrary number of vertices and indices. It does correctly buffer them and render them as long as the attributes are exactly 3 floats for position and 2 floats for texture coordinates in every single vertex. So not super flexible, but it does work, all right? That's all I care about. It works. Now how do we make it better and more flexible? However, this problem kind of undoes that because it does work for one object. But as soon as I want to put another object in, I've realized that the way I do rendering is flawed fundamentally. Okay, maybe not fundamentally, but if I want to have more than one mesh in more than one position, then I need to be able to acquire their global position and apply it to the correct buffer. That's the thing. Right now, it's a very precarious situation. I have 3 global variables, and they are all, I think, vectors right now, because fuck using fucking pointer arrays. Like, fucking hell, that was the most, dude, pointers and references to pointers, and what does it mean when a function takes a pointer and gives a pointer, and when you give that a object and not a pointer, it becomes a pointer to the object. Using vectors is really nice and really easy. I understand why everyone just suggests you use vectors. You know, tiny bit of overhead perhaps, but like, holy fucking shit. Also the fact that, like, you know, if it's more than 8 digits because it's a fucking, you know, the 8, whatever. The size of like the pointer can only be up to 8 or some shit like that. I don't remember exactly, but it's annoying. It's difficult. Vectors are great. Vectors are awesome. So right now there are 3 vectors that are global variables, and they are global storage for buffers, and one of them is for buffers. I think VBOs. One of them I think is for EBOs, and one of them has been a day or two since I've looked at my code, and one of them is for index number, and they're buffered in such a way that you can just iterate through all the lists, and they should be in the right order. That is scary, because just they should be in the right order means as soon as this becomes a multi-threaded program, which I want it to become, a single-threaded game engine and renderer is not gonna fly. As soon as it becomes multi-threaded, there is the chance, possibility, non-zero chance that that these vectors could be out of sync. So but this comes back to algorithms in C. There is examples in the very beginning of the book when talking about, you know, simple algorithms. They talk about path compression, tree representation of weighted quick union, and quick find, and big O notation later on, which is really fucking crazy. I had to watch a YouTube video afterwards to fully understand it, because this is a dry fucking book. 1999. I mean, it was written way before, but like 1998, copyright, fucking, like, yeah, no, the dry fucking book. Good fucking book, but dry fucking book. Anyway, but that kind of relates, because I need a way to pair members in an array, and I might even have to figure out if they're all connected, which is, you know, a problem in here, which is cool. But more than that, this book is helping me learn fundamentals of algorithms, fundamentals, data structures, sorting, searching. Like, that's on the front of the book. So it'll help me learn a deeper, lower level understanding of programming and what it is. And that'll help me with this. Because once I understand like what data is being transferred. That's all I need to know. That's all I need to know. If I learn stuff in this, if I use this and read that and learn that, then I don't need to learn a whole bunch of difficult concepts, you know, using OpenGL and C++ and game engine stuff. I mean, maybe, but I just need to know, okay, when you're rendering, what data is going where, when, and how is it supposed to get there? And what is it supposed to be? That's all I need to know. I don't need to know about what's the most, you know, what's the best way to store buffer objects and what's the best way to supply vertex data to the GL buffer data function, and you know, how do other people do it, and do you put it in the main loop, or do you make another loop, or do you do threads? What happens when you do threads? All I need to know is, what data do we have? What data are we making? What data goes where? When does it go there? How does it go there? You know, very basic, simple questions, and then how best to do that. And that's when I can go into higher level ideas and look at what other people do. And I'll have a better understanding of that because I'll know, okay, why are they doing it like this? And I'll know to parse out certain things. Like I'll be able to look at, I've been trying to look at Godot's, I have saved their pipeline graphic for the rendering pipeline, their flowchart. But I've looked at their code and it's like, there's a lot of stuff going on and I get lost. And granted, it's because it's a large code base, but if I learn the fundamentals, if I learn algorithms, if I learn the basic core ideals, then I'll be able to parse out, okay, all this data is for error handling, or all this data is for a unique arbitrary case, or all this data is for a specific condition. Only the stuff for rendering in OpenGL is here, and I know that because I know they're supplying a bunch of float data, they're supplying a bunch of unsigned integer data, they're supplying whatever. They're converting it like this, they're processing it like this, and that is, I know, the type of basic data that you need, use, have, convert, whatever. So very excited. He gave me, my dad, because these are the books he used when he was learning how to program, you know, back in the early 2000s, the part 5 to algorithms in C, TCP/IP sockets in C. This is the good shit. This is where when you want to hack things. Algorithms of the Intelligent Web. My dad helped build Ask Jeeves, and so that was one of the things he read while he was doing that. So, you know, all in all, really good shit. I'm really excited to get into this and learn the basics of programming, the actual basics of programming, not any one specific language. And this is what I've been wanting. And it's hard because, you know, it's dry, but if you can do it, there is a lot of merit to knowing the basics. You know, you get down and to a point it is, you know, like, you don't need to learn this kind of stuff. All you need to know is higher level things, you know, like at certain degrees of what you want to do with programming, but you know, that is, there's like a level of like, it's not really necessary, it's not really necessary, it's not really necessary, it's not really necessary, but then you break a certain point. And all of a sudden, now if you learn all of this super low level stuff, like to the point of it being theory and not like, I mean, this is practical and there are examples and stuff, but there's a lot of theory. Now it's like, well, if you know this, you don't need to know any of this. It translates almost directly to any language, idea. Like, these are the thought process, not just like examples, boilerplate. Like, these are how you should think about the process. So hopefully I can get through this really quickly and start putting it to use. Get myself a nice job, game programming or something. That would be really cool. But for now, you know, I take my intermediate knowledge of programming and I try to gain a lower level understanding of everything. That way I can be ahead of the curve. Because it doesn't matter what new programming language comes out. It doesn't matter what new, technologies are developed. It doesn't matter what new breakthroughs are made. If you know the basics, the basics, you can adapt to anything. That's what I want to be able to do. I don't want to just know Python. I don't want to just know how to do, machine learning Python setups. I don't want to know how to mod a game in C#. I don't want to know how to use Godot to make a video game and using GDScript. I want to know how to program anything, anywhere, anyway. And this is going to get me there. And on the side, I can continue to learn, or maybe after this, probably I can continue to learn assembly for the Z80 processor because I have an Osborne one in my car. And I've been wanting to actually program for that in assembly and make something fun. Anyway, that's the update. Yeah, work on the engine has slowed, but work on my knowledge has just begun. And the more I learn about this, I'm still chipping away at the engine, but more I read this, the more I go, oh. So, good stuff.